Let's now look at some applications where the relationships between prediction, making decisions based on the predictions, and then controlling one's actions become abundantly clear. First example is robo-soccer. I don't know if many of you have tracked this, but there are regular competitions of people building small robots and getting them to play soccer. And this is a little photograph of one such competition. Imagine what this robot has to do. It needs to predict where the ball will be, decide the best path to get to the ball, and navigate there. And that's the basic thing that it needs to do if it doesn't have possession of the ball. Prediction is very critical. The ball may be moving with a certain velocity, and the robot needs to figure out where it's going to go, much like our very first example of the paddle game in the 0th lecture of this course. Another example is self-driving cars. You might have heard that Google, for example, is developing a self-driving car which has already driven over 100,000 kilometers, both in rough terrain as well as urban environments. Imagine what such a car has to do. It needs to predict the path of a pedestrian that it's seeing, decide the path it needs to follow to avoid that person, and then steer the car appropriately. Prediction, decision, that is optimization, best path, and then control or steering. We've all heard about the intelligent energy grid, which is going to change the way we consume electricity and natural resources. These things happen already today. Grids predict the energy demand, decide and control the distribution, all using techniques very similar to those that we have discussed, and these are already in place. Think about a business having to deal with a supply chain of products being produced based on raw materials which have to be sourced from a variety of different locations around the world. In order to decide which products to produce in what quantities, a supply chain needs to predict the demand for every product. Based on that, decide the best production plan based on the raw materials available and which products require which raw materials in which quantities, an optimization problem, and then execute it. A very complex control system indeed, which involves many moving parts and many pieces of a complex organization. Another example of supply chain is when products are manufactured all around the world, there could be a variety of risks. You could have floods or fires or unstable political conditions in different parts of the world which might pose a risk to one's supply chain. These kind of events can be detected increasingly from social media sources such as Twitter. Once such risks are detected or potential risks are detected, they need to be evaluated, whether or not they pose significant risks, and if so, the production plan needs to be replanned and then re-executed, or amendments to that plan need to be put into place. Finally, in marketing, when one is trying to sell products, one might need to predict the demand for a product, decide the promotion strategy by region based on the demand, and then execute the promotion strategy. In each case, we have the predict, decide, and control piece. These examples are not necessarily simple, but they can get increasingly complicated, as we shall see in a minute. Think about the examples below, which are grayed out now, and compare these to robo-soccer, self-driving car, energy grid. There does appear to be something fundamentally different about the ones at the bottom and the ones at the top. For example, the ones at the top are possibly executable or implementable using, say, a system which will predict the ball, directly take that prediction, decide the best path using some optimization techniques, and then navigate there using a simple control system. Similarly for self-driving cars, in fact, autopilots for aeroplanes are already part and parcel of everyday life. Cars are a little bit more complicated because of things like pedestrians and overtaking and lanes. But still, one can imagine with a suitably implemented system actually doing this. And similarly, the energy grid, as I had said, is already there and running already today. However, consider some of these examples below. Detecting potential risks from, say, tweets is possible, but then evaluating their impact requires a certain degree of fairly complicated reasoning. Similarly, predicting demand might be easy, but deciding the right promotion strategy by region might be a fairly complicated exercise. The problems above can also be made more complicated. For example, in addition to predicting where the ball will be, one might want to predict how other players will move, and this requires a certain degree of reasoning. Similarly, one might need to predict traffic based on possible inputs from many different people about where they want to go that day. Based on that, you might want to decide the optimal routes to a destination for everybody. And in some sense, a self-driving car might manifest itself into a network of many self-driving cars, along with people deciding where they want to go through their cell phones, and all the cars magically getting everybody to where they want to be with minimal traffic. A fairly utopian situation, but in principle possible. Again, a little more complicated decision making needs to happen. Reasoning to a certain extent, a lot of planning for sure. Similarly, in the energy grid, you might want to predict the supply by how green that supply is, whether it's coming from a wind turbine or from a coal-fired power plant, and adjust the prices optimally so that one could maximize the utility of the green power when it's available, that is, say, when the wind is blowing, but not necessarily make people pay too much if there's no alternative to a coal-fired power at a particular point in time. Again, more complicated predict, decide, control systems. All of these are today being built or are already in production to a certain extent, and because of the number of devices, the number of sensors, and information on the web, on social media, and the interconnection of almost everything in general, I definitely call all of these potential web intelligence systems. They incorporate many of the techniques that we have talked about, as well as many that we haven't, such as optimization and control. Well, having seen a number of applications, this lecture we're talking about prediction and certainly learning. So we'll now briefly come back to the techniques and try to see which techniques one should use in which situations.